Okay, so this lesson looks at the energy changes in chemical reactions. So all reactions will absorb or give off energy to the environment. And there's two types that you will come across: exothermic reactions and endothermic reactions. So let's look at exothermic reactions. These are reactions where energy is released from the reactants to the surroundings or the environment. So energy is released, and the environment then gains the energy and it's going to get warmer. So, an example would be combustion of wood in a fireplace, and the living room gets warm. So, more bonds are made than are broken, and heat exits the system. Okay, so, try to remember that: exothermic heat exits. Okay, so here's an example. You have CH4 plus 2O2, so you have a combustion and energy is given off. So you'll find that energy is found on the product side. Okay, so that's an important indicator when you're looking at the equations, that when heat is on the product side, then you know that it is an exothermic reaction because heat is given off. You treat it like one of the materials in the equation, so like reactants, products. So the products here are heat, water, and CO2. Now, another way you might see exothermic reactions written would be, you would see it kind of this thing called delta H, delta meaning change in energy, and it's set off to the side of the equation. And it's saying here like delta H is negative 891 kilojoules. So here, because you see that negative, you would assume then heat is given off. And an example would be something like this. Here you have the reactants, they have 40 joules of energy. The products have 10 joules of energy. So if you look at the change, it would be products minus the reactants. So the products are at 10 joules and the reactants are at 40. So you go 10 minus 40 is a negative 30. So anytime you get a negative value for a delta H calculation, then you know that you have an exothermic reaction. Now, the reverse is true for endothermic reactions. So, endothermic reactions absorb energy from the environment. So, the environment actually gets cooler and the system itself gets warmer. So, more bonds are broken than made, and heat enters the system. So, it's endothermic. So, let's think of heat entering the system. So, if that is the case, then you will find that the heat term is on the reactant side. Okay, so energy was added, heat energy was added to the reactants to get this reaction to get going. Okay, and once again, you might see that the delta H term is set off to the side as a positive value. So anytime you see a positive value, you know that energy is being added into the system. So an example would be, here you have the reactants at 10 kilojoules, and here you have the products at 40. So if you are looking at this from a mathematical point of view, you would go change in energy is equal to heat of the products, which is 40, minus the heat of the reactants, which is 10. Okay, and then you would get a positive value of positive 30 joules in this example. So when you have some time today, try these questions in your workbook. Remember questions 70 to 80, and then you're going to learn much more on endo and exothermic reactions in Chemistry 12. So there's a whole unit designated for reaction mechanisms, changes in energy, etc. in grade 12.